Now let's talk about inverse trig functions and their derivatives. So let's do a little bit of review first. So you may not have done problems exactly like this, written this way, but I know you've done them in a similar way. So first of all, I want to point out this is arctan. That's the same as saying inverse tangent. It's just a different way to write it, and that's just to reinforce that it's not the reciprocal. So when you see inverse trig functions, sometimes it will be written with that -1 in the exponent, sometimes it will say arc. So if we want to find sine of arctan of 3/4, well, what we really want to figure out is what this angle is. Arctan of 3/4 has to be an angle. So we're going to rewrite that in terms of tangent instead. So it means tangent of theta is 3/4. Now that's not like a value you have memorized, but you should remember that from SOHCAHTOA that tangent is opposite over adjacent. Okay, so that means I can draw a triangle, a right triangle. Let's say this is my angle theta. My opposite side would be 3. My adjacent side would be 4. Now I can find my hypotenuse using Pythagorean theorem. That would be 5. It's a 3, 4, 5 triangle. And so then what this is asking me to do is to find sine of this angle, theta, so sine in this triangle. So this inside part helped me set up this triangle. Now I find sine. Sine is the opposite over hypotenuse. And so this would be just 3/5. Opposite over hypotenuse. Okay? So the inside part, once again, tells me how to set up my triangle, and then I'm going to find the trig function of that. So b is the same kind of idea, cosine of inverse sine of x, but instead of having a number like 3/4, we just have this variable x. So we're going to think about that as saying sine of theta is, instead of just x, we're going to think of it as x/1. And so again, that's opposite over hypotenuse. So when I set up my triangle, my opposite side will be x. My hypotenuse will be 1. So I can use Pythagorean theorem there. I would have x squared plus something squared equals 1 squared. So that something squared is 1 squared minus x squared, and then take the square root. So this is square root of 1 minus x squared. So if I want to find cosine of that, cosine is adjacent over hypotenuse. So my cosine would be square root of 1 minus x squared over 1. Okay, so this is how we do it with constants. We do it the same way with variables. Okay, so let's say now we want to find the derivative of y equals arc sine of x. So again, that's inverse sine. So we want to know how would we find the derivative without using an inverse trig function. And so the way we get rid of an inverse trig function is by doing the composition with a regular trig function. So essentially what we're going to do is take the sine of both sides. Because the thing that cancels out an inverse sine is a sine. And so then what I would have is sine of y equals x. So now I no longer have an inverse trig function here. I can go ahead and take my derivative, but I'll have to use implicit differentiation. So the derivative of sine of y is cosine of y, but then I have to multiply by the derivative of y because I have something besides an x inside the cosine times dy dx. That's equal to the derivative of x, which is just 1. Now let's solve for dy dx. dy dx is 1 over cosine y. But y was arc sine of x. It was given to us here. So this is 1 over cosine of arc sine of x. But from up here, we know that cosine of arc sine of x is square root of 1 minus x squared. You could redraw this triangle right here. That's what's supposed to go there. Okay? So what we get is that the derivative of arc sine of x is 1 over square root of 1 minus x squared. Seems weird that it's there's no trig function in there when you take the derivative. It's just this, but remember it comes from SOHCAHTOA and your right triangles. Okay, here are the last set of derivative formulas you'll need to have memorized. These are all on your Stuff You Must Know cold sheet once again. So the left side has just the regular formula, just if there's an x inside. So this inverse sine is the one we just talked about. Notice for the derivative of inverse cosine, it's just the negative of what we had for inverse sine. So just negative 1 over square root of 1 minus x squared. And for inverse tangent, it's 1 over 1 plus x squared. So notice there's no radical there. The derivatives on the right side are just your chain rule version. So if I have something besides an x, it will replace the x, but then I have to multiply by that derivative. Same thing for inverse cosine and inverse tangent. Okay, so we'll mostly be using these formulas over here because it's the more interesting case. So in part A, we have the inverse sine of 4x. We're going to find this derivative. I'm going to put the parentheses in there just to be clear. So that 4x is my u in this case. So I'm going to use this formula, the derivative of inverse sine. And so my dy dx is 1 over square root of 1 minus whatever was inside. So that's the quantity 4x squared. Make sure you use parentheses there. And then times the derivative of 4x, which is just 4. So again, I'm just multiplying by the derivative of whatever was inside inverse sine. Let's simplify just a little bit. We'd have a 4 in the numerator. In the denominator, have square root of 1 minus, this is, I have to square the 4 and the x, so it's 1 minus 16x squared. Okay, in B we have inverse tangent of x cubed, same idea. I'm going to use my inverse tangent formula now. So my inside is x cubed, so my derivative 1 over 1 plus x cubed, that whole thing squared, then times the derivative of x cubed, which is 3x squared. Again, we can simplify a little bit. 3x squared in the numerator, 1 plus x to the 6th in the denominator. Okay, part C. Now we have inverse cosine of e to the negative x. So again, this e to the negative x is inside my inverse cosine. We use my inverse cosine formula. Negative 1 over square root of 1 minus e to the negative x squared times the derivative of e to the negative x, which is just negative e to the negative x, or e to the negative x times 1, times negative 1. If I multiply that in my numerator, I would just have a positive e to the negative x. My denominator then, when I have e to the negative x squared, I multiply those together. So I have square root of 1 minus e to the negative 2x. Part D, we have x inverse sine of x. And so what's going on between there, that's being multiplied. So we have to make sure to use product rule, x and inverse sine of x. Those are our two parts. So for my derivative, I have 1 times inverse sine of x, which is just inverse sine of x, plus x times square root of 1 minus x squared, the derivative of that. So I'm just going to go ahead and put the x in the numerator there. And that will be our answer. We can't really simplify it anymore. Okay, in part E, we have inverse sine of 2x, the whole thing squared. This is going to be one of those peanut M&M problems. Okay, so we've got 3 layers. We've got the squared, we've got the inverse sine, we've got the 2x. Okay, so we're using chain rule here. So the derivative of something squared is 2 times that something. Now I'm going to do times the derivative of that. So the derivative of inverse sine of 2x, 1 over square root of 1 minus the quantity 2x squared, then times the derivative of 2x, which is just 2. Let's simplify that sum. So we have in the numerator all of this, 4 inverse sine of 2x, all over square root of 1 minus, make sure you square both of those, 4x squared. All right, for f, we have natural log of inverse tangent of square root of x. I'm going to write it down here. It's going to be a little bit long. So again, this is like a triple, if not quadruple, chain rule kind of problem. So the derivative of natural log of something is 1 over that something. Times, now I'm going to take the derivative of inverse tangent of that. So derivative of inverse tangent is 1 over 1 plus x squared. So 1 over 1 plus, instead of x, we have square root of x squared. And then times the derivative of square root of x, which is x to the 1/2. So that derivative is 1/2 x to the negative 1/2, or 1 over 2 square root of x, if you simplify that. There's not too much to do here. We can put this all under the same denominator if you want. Usually we would put the polynomial parts in the front. So we've got 2 square root of x times 1 plus square root of x squared is just x times inverse tangent of square root of x. All right, and now our last one. We have x inverse sine of x plus the square root of 1 minus x squared. So again, we're going to have to use product rule on this part. And then this part we'll use chain rule. Okay, so product rule and chain rule here. So that's 1 minus x squared to the 1/2. So we just did this first part up above, so we can just repeat it. The derivative of x inverse sine of x is just inverse sine of x plus x over square root of 1 minus x squared plus, now I'm going to have to do my chain rule here. That was 1 minus x squared to the 1/2. So 1/2 1 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. So if I simplify this, I have inverse sine of x plus x over square root of 1 minus x squared plus, here I have negative 2x times 1/2, which is just negative x over square root of 1 minus x squared. And so what I'll notice is these two parts actually cancel out here at the end, and so my final answer is just inverse sine of x.